I see it also as an opportunity of unifying religion with science because very advanced scientific culture may do miracles as far as we are concerned. They could, for example, create life in their laboratories, or if they understand how to unify quantum mechanics and gravity, they might engineer a baby universe in their laboratories.
In this episode, I interviewed Dr. Avi Loeb, who has been the longest-serving chair of the astronomy department at Harvard University, a best-selling author and one of the most influential people in space, according to Time magazine. We discussed alien life, interstellar objects visiting the Earth, the limitations of multiverse, and time travel. We also discussed Dr. Loeb's exploration projects, including the ambitious Starshot initiative that is working on a technology that would allow to send probes to Alpha Centauri and reach it within our lifetimes. But before we start, please do me a great favor by subscribing to the channel and sharing your thoughts in the comments section. Let's continue growing this community together.
Are we alone in the universe?
Probably not, because we know that most stars, like the sun, formed billions of years before the sun, and there are tens of billions of them. And moreover, a significant fraction of them, somewhere between 3% and 100%, have a planet the size of the Earth, roughly the same separation. So what we find in our backyard is not unique or special. And under similar circumstances, I can imagine life forming and potentially technological life of the form that we have. And in fact, it could have happened billions of years ago around other stars. So I would say we are late to the party. And for us to think that we are unique and special is arrogant. So most likely, there are other students in the same class of intelligent civilizations within the Milky Way galaxy. And some of them are smarter than we are and much older than we are. And perhaps some of them are even dead by now. But our obligation as curious scientists, at least for myself, is to study our neighborhood and try and figure out if they're out there or if there are any relics from them. That I call space archaeology.
You think there might be somebody even just in the Milky Way, not let alone the other galaxies?
Oh, yeah, because there are tens of billions of stars in the Milky Way, like the sun. Of course, traveling from other galaxies takes a long time. So if I can imagine someone visiting us, it would be from within our galaxy. And the spacecraft that we used can cross the entire Milky Way disk within 500 million years using chemical rockets. So there was plenty of time for them to arrive to our vicinity. And over the past 70 years, we've been searching for radio signals, but that's a very primitive communication technology that we developed early on, in the past century, when we came across electromagnetism and quantum mechanics and so forth over the past century. And it's, as time goes on, we are developing other means of communication, like fiber optics or other techniques, and it's not clear that they're using it. And moreover, waiting for a radio signal is like waiting for a phone call at home. You need someone to call you when you're waiting, and it may not be the case. Maybe most of them died by now, and they cannot call us on the radio. And so there is a better approach. The radio signals, if they were sent 1 billion years ago, they are now 1 billion light years away. They escaped from the Milky Way galaxy, but any technological gadget like the spacecraft we've used to interstellar space is moving at a speed that is much below the escape speed from the Milky Way galaxy. So it's bound to the Milky Way by gravity, and we keep accumulating those gadgets that were sent by civilizations prior to us and in space, in interstellar space, and we can find them just like we find plastic bottles in the ocean. In fact, the plastic accumulates in the ocean so that in 2050 there will be more mass in plastic than fish in the ocean.
Wow.
So it just shows you that over time you can accumulate a lot of stuff. And I think it's misguided for us to look for radio signals instead of checking our mailbox. Maybe there are packages out there.
One of those packages might be the object called Oumuamua. Can you give us a background on what that was and what's interesting about that particular object?
Right. So I wrote my first paper about interstellar objects a decade before this one was discovered. And I predicted that the telescope, the survey telescope Pan-STARRS in Hawaii, will not find any rock from other stars, because based on what we know in the solar system, there shouldn't be many rocks out there for it to find any. And then in 2017, Pan-STARRS reported the first interstellar object to be found. It was October 2017, and it was as large as a football field, and the telescope discovered it as a near-Earth object. So Pan-STARRS was designed to find objects that come close to Earth and pose a threat. It was found that this object is actually moving so fast that it cannot be bound to the sun, and it was declared as the first interstellar object, given the name Oumuamua because it means a scout in the Hawaiian language. Now, the more we looked at it, aside from the fact that it was unexpected, it looked strange, because as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that it has an extreme shape, and the best fit to the variation of light was that of a flat object, disc-like. And then it was pushed away from the sun by some mysterious force, because there wasn't any evaporation, cometary evaporation, any gas or dust around it. And nevertheless, there was this push away from the sun that is usually associated with evaporating gases that give it the rocket effect for any comet. So it was not a comet, and yet it exhibited this push. And I suggested it's just a reflection of sunlight from the object that is pushing it. And for that, the object had to be very thin. And I said, well, such thin objects are not made by nature. They must be made artificially. So maybe it's a technological relic. And most recently, I suggested maybe it's a piece of a broken megastructure, like a Dyson sphere that was envisioned back 60 years ago by Freeman Dyson, that, you know, some advanced civilizations will surround their host star with tiles of material that will harvest all the energy from the star. And, you know, after 1 billion years, the civilization may be dead, or the star will evolve and push away those tiles, and you may get some pieces of it when it's broken. And maybe one of them was the Oumuamua, I don't know. But at any event, 3 years later, the same telescope in Hawaii discovered another object that exhibited a push by reflecting sunlight, no cometary tail. It ended up being a rocket booster that NASA launched in 1966. And it had thin walls. That's why it was pushed by reflecting sunlight, a large area for its mass. And also it didn't evaporate like a comet because it was made of stainless steel. So we know that this one, which was called 2020 SO, was artificial in origin because we produced it. The question is, who produced Oumuamua? And I should say, you know, the experience is very similar to going to the backyard of your home, and you're used to finding the rocks that you always see there. And so if an object comes from the street, you say, oh, the first thing you say, it's a rock like the rocks I have in my backyard. But every now and then it may be a tennis ball that was thrown by a neighbor. So that's the kind of experience that I had encountering this object. And then 2 years later, in 2019, together with my student, we discovered that, in fact, before Oumuamua, there were 2 objects from interstellar space that were identified, and they were meteors. They were roughly 1 meter in size, and they collided with Earth and produced a fireball. Oumuamua was the size of a football field, about 200 times bigger. But these were much smaller, and they were detected by the US government because they exploded as a result of the friction with air. And so we argued that the first interstellar object was actually discovered back in 2014. And then the second one was March 2017, about 7 months before Oumuamua. And of course, you know, there was a lot of skepticism among my colleagues, but then the US government released a letter to NASA that confirmed that the 99.999% that the meteor from 2014 came from outside the solar system based on its speed. Wow. And they released data about it that allowed us to infer that it was tougher than iron. So its composition was very different then the meteors, all 272 of them in the same catalog that NASA compiled, it was tougher than all of them by at least a factor of 10, based on the data that it exploded low in the atmosphere and was moving really fast. So there was a lot of stress on its surface. We could tell that it's tougher than all meteors ever discovered, all the space rock. So we are going on an expedition to the Pacific Ocean in a few months to examine the composition of this meteor from 2014. We want to find out whether it was natural in origin, or maybe it was a spacecraft from another civilization.
Yeah, we covered quite a bit of ground there. I think you talked about Oumuamua, and this is a Galileo project. Is it what it is?
Yeah. So after I wrote my book about Oumuamua extraterrestrial, a few multi-billionaires came to the porch of my home and decided to give me funding for my research. They were inspired by the vision. One of them, Dr. Frank Laukian, co-founded with me the Galileo Project, and basically it's a scientific program to explore anomalous objects like Oumuamua or like these meteors that I mentioned before, to figure out whether they originated from some technological extraterrestrial civilization. And so we have 3 branches within the Galileo Project. By now there are 100 members and about 1,000 volunteers that wanted to join us. And the first branch is to find the next Oumuamua. I call it dating the next Oumuamua. There is a dating app, which is a telescope in Chile called the Vera Rubin Observatory that will start operations in about a year and has a 3.2 billion pixel camera that would allow us to survey the southern sky every 4 days. And it's likely to find many more objects like Oumuamua, and we can look at them both from Earth and also with a Webb telescope, which is 1 million miles, 1.6 million kilometers away from Earth. Having 2 vantage points looking at the same object will allow us to pinpoint its trajectory in 3 dimensions and figure out whether the trajectory is shaped just by the sun's gravity, or maybe the object has some propulsion. So that will be very exciting. So that's one branch of the Galileo Project. Then the second branch is going after the relics, the fragments left over from interstellar meteors, like this expedition to the Pacific Ocean that we will have in a few months, and try and figure out the nature of those unusually tough interstellar meteors. And the third branch is attending to the reports from the US government that they find unidentified aerial phenomena. And over the past year, there were hundreds of reports. And there is a new office in government, in the US government, that looks into all the reports and the data that is obtained. And the government is not a scientific organization. So we assembled an observatory that is currently on Harvard University property, and it's monitoring the sky 24/7, and it's doing it basically taking a movie of the sky in the infrared, the optical, radio, and audio, and then the data is fed to the cloud, and we are analyzing it with artificial intelligence software that attempts to classify objects in the sky, basically distinguish between natural objects like birds and human-made objects like drones, balloons of the type that the US government shut down, or perhaps airplanes. And then the question is there anything else out there? Anything that may have originated from extraterrestrial origin.
And let's talk about each of these branches a little bit deeper. So the first one, let's talk about Oumuamua again. My understanding is that we didn't realize that object is that interesting until a little too late, right?
Right. And that's because astronomers are used to looking at rocks from the solar system. So they said, well, okay, it's a rock from another star. And once it became clear that this is very different, it's not a comet of the type that we are used to because there was no evaporation noticeable around it, and it was not an asteroid of the type that we're used to, just a bare rock because it was pushed away from the sun. The question is, what's the origin of the non-gravitational acceleration? And it has several other anomalies, and when they were recognized, it was too late, because it's just like going on a date and liking the person only after the person left through the door, and then you can't find it anymore. So, of course, the trick is not to get obsessed with one particular object, but to continue dating other objects. And most of the time, we will swipe to the left if an object looks like a comet or an asteroid that are familiar, but we might find more of the same. I should also point out that the reason this object was found is simply because it came close to the Earth. It was the size of a football field, big enough for us to see the reflection of sunlight. And it was moving, at the same order of magnitude as the speed of the rocks that we usually find in the solar system. Now, there may well be a population of objects that is either moving much faster, than the characteristic speed of tens of kilometers per second that we are looking for, or much smaller objects than a football field, because NASA never launched a spacecraft as big as a football field. Okay, so there may be many more objects that are the size of a person, and they're passing in the dark. We can't see them with existing telescopes. There may also be a large population of objects moving much faster than the rocks in the solar system that we are not geared to looking at. I should even, it was really surprising to me to hear. I asked someone who is working on the pipeline of the Vera Rubin Observatory, and I said, okay, is the software geared towards finding interstellar objects that are not bound to the sun? And the answer was, no, we are just looking for objects that we are familiar with. And this is after Oumuamua was already discovered. So, we are now working with my postdoc on trying to devise this software that will identify interstellar objects. It's really surprising that very often, scientists follow wishful thinking. And just to illustrate that even better, a couple of weeks ago, there was a paper in Nature, the most prestigious journal, which argued that actually Oumuamua was a regular comet. It was made of water ice. And the only reason we didn't see the cometary tail is because as the iceberg was moving through interstellar space, it was exposed to cosmic rays, very energetic particles that bombarded its surface and broke the water molecules into their constituent hydrogen and oxygen. So if you break a third of the molecules that make up the iceberg, the idea was the hydrogen could evaporate when the object comes close to the sun, and then you will not see the cometary tail because hydrogen is transparent. That was the idea. The only problem is they made a mistake in calculating the temperature, the surface temperature of the object. They basically balanced the heat input from sunlight to the radiation coming out from the surface, but they forgot to account for the energy that needs to be invested in dislodging the hydrogen from the lattice. And when you include that, you find that this term in the energy equation is 1,000,000 times bigger than the terms that they considered in the paper. So we actually pointed this out a day after the paper came out, and I contacted 14 science journalists telling them, look, you just reported in the most prominent magazines and newspapers about this Nature paper that perhaps Oumuamua is just a water iceberg, but in fact it's wrong because they made a mistake. I'm sorry to tell you, but we wrote a paper and here is the calculation. So you can just say Avi Loeb, along with his colleague Thing Huang, found through a calculation that there was a mistake. And they said to me, most of them said, sorry, we will not write about this or add a footnote about this because we don't want to confuse our readers. And I thought to myself, look, in politics, we always complain about politicians not attending to rational thinking or to evidence. Why is it so difficult to add a correction or a footnote saying that, in fact, there is a claim that this calculation is wrong. And by the way, this was 2 weeks ago. We posted our paper publicly. The authors of the original paper had plenty of time to respond or to explain why, including the correction, basically it does not rule out their model. But they didn't do any of that. And they just made some diplomatic comments about this without attending to the substance. And I find it to be depressing because it's basically wishful thinking. One of the authors of this paper, the Nature paper, he told me about 6 months ago, he said, I just wrote a review paper about the comet Oumuamua. And I said to him, what do you mean by the comet Oumuamua? We both know that it didn't look like a comet. So how can you call it a comet in a review paper that is supposed to summarize everything we know about it? And he said back then, 6 months ago, he said, oh, I call it a comet because I have this theory that it showed a cometary tail when we didn't look at it. And when we looked at it, the cometary tail was off. And I said to him, well, that sounds like going to the zoo and looking at an elephant and then saying, this elephant is a zebra and it shows its stripes when we look away. And how can that be the mainstream? Now, of course, the reason he's saying that is in order to be liked by his peers, in order to make the statement that this is actually nothing unusual. This object is well known. It's a comet. Don't worry about it. I call it a comet. You can feel comfortable about it because I call it a comet. And I say, it reminds me of Hans Christian Andersen. I play the role of the kid who said the emperor has no clothes. And here the emperor is Oumuamua and the clothes are the cometary tail. I said there is no cometary tail. What are you talking about? And other people are saying, what do you mean? The cometary tail or the emperor has beautiful clothes, but they are invisible. So can you believe it that mainstream people would argue that now on an object that we observe and say, oh, the clothes are very fancy. Look at this emperor. It's just like, we imagined it to be.
So what's the motivation though? Like, is the idea of not able to explain Oumuamua so terrifying to them that they don't want to?
Yeah, I think fundamentally there is a resistance to new knowledge by experts, people that are used. I mean, think about a cave dweller that plays with rocks all of his life and then finds a cell phone. How would the cave dweller respond to that? He would say, it's a rock of a type that I've never seen before, but it's a rock. It's just a shiny object, a rock, and throw it away. Now, if the cave dweller has a kid, there is a chance that the kid will say, wait a minute, daddy, I want to have a look at it, and then start to press some buttons and realize that it's not a rock. So I am trying to play that kid, okay? And I would love to see a button. But the problem is that when people say, it's an extraordinary claim that requires extraordinary evidence, and then they shy away from seeking that evidence, they just say that in order to stop the conversation. And moreover, some of them would say, actually, it's not even unusual. It's actually a comet. Let's believe that it's a comet. And everyone say, oh, yeah, it's a comet. We don't need to do anything. Then, of course, it's a self-fulfilling prophecy. You will never find new knowledge as a result of that. And my point is, it's unfortunate because here is an opportunity. Nature is telling you something. It tells you, here is the first object that you identified from outside the solar system. And it's not the same as the objects you have witnessed already. That's a gift. That you should be intrigued by that because there is an opportunity to learn something new, even if it came from a natural source. So instead of following curiosity, I mean, the way that a kid does it, what experts are doing is suppressing any innovation by saying there is nothing new to be learned from that. Our past knowledge represents everything. Everything in the sky will be rocks. And if it doesn't look like a rock that we're familiar with, okay, well, then it's made of some hydrogen, or then it's made of nitrogen, or it's a dust bunny. And this is really frustrating because I came from the field of cosmology, where we don't know what most of the matter in the universe is. We call it dark matter. And we know that the solar system doesn't have evidence for that dark matter. So among cosmologists, it's clearly understood that you can't say, oh, it's actually made, the dark matter is made of a hydrogen iceberg or a nitrogen. You can't say that because we know that it's not ordinary matter based on various arguments. And so it's completely legitimate for people to say, oh, maybe the dark matter is black holes. Maybe the dark matter is the lightest supersymmetric particle. Maybe it's an axion. So I grew up in this culture for decades that was suggesting all kinds of possible explanations for the dark matter. It's completely legitimate to put it on the table. Nobody said, oh, an axion? That's an extraordinary claim that requires extraordinary evidence. We shouldn't even fund such search. In fact, there are experiments funded to look for the axion. And in fact, the Large Hadron Collider was looking for the lightest supersymmetric particle. It cost $10 billion. We didn't find it. So it's part of the vocabulary of any frontier in physics, if there is a puzzle, to try and figure out what it is by suggesting ideas and then testing them. And only in this context, we are so in such a primitive mindset where people push back and try to cover up anything unusual about the first interstellar object. And I say, okay, you want to cover up this one? What about the meteors? 2 meteors that were tougher than all space rocks we had ever seen, 272 of them. How do you explain that? And what they say, oh, this never happened. We don't believe the US government. These are not interstellar. Or the data is, and I say, well, how can you not believe the US government? They need to monitor ballistic missiles and they need to know whether it will hit Boston or New York City. They have very good data. And they wrote a letter, and they wrote a letter to NASA saying that they confirmed the finding. So in response to the letter, our paper was accepted for publication, but I still see here and there comments like, why should we believe this letter?
Fermi Paradox, right? About if life exists, why don't we see it? Maybe that's why, because we don't even look for it.
Well, so the way Fermi phrased it, he was in Los Alamos having lunch, okay? And I think it's very presumptuous of him to just say, where is everybody? Like, you sit at your sofa at home and you say, I don't have any neighbors, because my neighbors, I don't see them around in the living room here. Well, to find your neighbors, you have to look through your windows and you better use a telescope. It's completely ridiculous. I mean, space is so vast and time is so long compared to the 1 hour lunchtime that you had in Los Alamos. Why would you have clear evidence for them exactly at that time? If they visited, let's say, 1 million years ago, 1 billion years ago, you were not around. If there were signals coming out when, lots of other civilizations perished as a result of their star becoming a red giant, the way the sun will become in 1 billion years and will basically boil off all the oceans on Earth. So other civilizations went through that and they perished on their planet. And there must have been some cries for help, but they predated us. We just came over the past few million years. You have to understand the big picture. You can't just say, where is everybody? Like, they could have been there, but they are dead by now because their star evolved the way the sun will evolve and make Earth inhabitable for life. So you have to think about those implications, and that means you need to search. And only over the past decade, we started searching for objects, interstellar objects, and finding them, only over the past decade. So it was completely premature for Enrico Fermi not to use even a telescope and ask this question. And for 70 years, we've been looking for radio signals, but that may be misguided, as I said before. So, and besides, if you see of some of the trends that human civilization is going through, for example, we are developing artificial intelligence systems that will soon overtake us in terms of their intelligence, because right now, GPT-4 has 100 trillion connections, which is shy by a factor of 6 of the human brain that has 600 trillion synapses. And so GPT-5 will potentially look pretty much like a human or better in terms of intelligence. So there is a potential risk, existential risk, from AI deciding that humans are not really necessary, like, let's say, decades from now or centuries from now. So maybe we just have a few centuries left. Okay, that's one possible explanation. Where is everybody? They are dead. But if they sent equipment to space the way we did, we could find the relics, even if they're dead. Another possibility, if you look at the metaverse, lots of people enjoy putting goggles on their head and living in a virtual reality, and other people take recreational drugs. So just imagine a planet where AI takes over the routine tasks so that humans have the freedom to do whatever they want for their pleasure. And most humans decide to enjoy themselves in a virtual reality, either communicated through goggles or through recreational drugs or whatever. Obviously, in this virtual reality, such a civilization will never communicate with the outside world, okay? So that's an end state for communication, simply because this civilization, you might say, is stoned. It's not communicate, it's out of this world. And that's also possible, as an end state. But another end state is that, they left their planet and they realized that actually making a lot of noise is not beneficial for their longevity. They have sent out probes that are, pursuing their goals, but they are doing it quietly and on smaller scales, and not communicating with huge signals that we can pick up across the galaxy.
Which is kind of actually, reasonable thing to do. Like if you look at the history.
Yeah, exactly. I mean, if you look at nature, dandelion, for example, the flower, has these seeds that get spread and permeate the longevity of the DNA of that flower, and by settling into places. So you can imagine a civilization sending probes like dandelion seeds that spread across the Milky Way galaxy in the habitable regions. And the question of what these probes are pursuing depends on the objectives of the civilization. But for example, if you have AI, I call them AI astronauts, or systems that use artificial intelligence to be autonomous, to learn from experience, and then they are equipped with 3D printers, they can reproduce, for example, the life that they, on the planet that they came from, elsewhere. So that's one way of spreading what you care about. But there are many things that they can pursue, and we don't know what they are. And until we find those gadgets, those probes that might be functional, we will never know. Of course, what we can find are either space trash, like I mentioned before about Oumuamua, things that are not functional, or we might find functional devices. These are the two forms, like the unidentified aerial phenomena. So we should be agnostic and just look around.
You're saying so many interesting things. I'm sure my listeners are mad that I'm not following up with you to get a little deeper into each of them. So in terms of the probes with artificial intelligence, basically it's because you're saying it's because of time it takes to travel. There is no living organism can actually be on the that spaceship or whatever it is.
Exactly, because natural selection on Earth, that's the origin of us, so to speak, according to Darwin, and that selected the fittest to survive on the surface of this rock, okay, that we call home, the Earth. And we are not suited for long journeys through space. First, because it takes a long time. Even light takes 4 years to get to the nearest star, and 50,000 years to cross the Milky Way disk of stars. So it's a very long journey, and the spacecraft that we built so far can move at a speed that is 10,000 times slower than the speed of light. So it takes 50,000 years to get to the nearest star with the kind of probes that we sent out, and it will take 500 million years to cross the Milky Way disk with the chemical propulsion. And so it's a very long journey, and I don't see how humans can go through many generations or be frozen. It's much easier to put an AI astronaut on a spacecraft, let it be dormant until it's time for action, and also to protect it from the hazardous radiation that is out there, like cosmic rays and the vacuum of space, ultraviolet. It's much easier to manufacture electronics that will withstand those extreme conditions and cold temperatures. So I'm personally very proud of our technological kids. As much as I'm proud of my daughters, I'm also proud of any AI astronauts that we may send. I would hate to send my daughters. I know that Elon Musk dreams of dying on Mars. I don't wish him that. I think that if he ever goes to Mars, he better go into a lava tube. These are caves that will protect his body from cosmic rays. It's just too dangerous to be on the surface of Mars. The temperature changes from like 20 to minus 70 in one day. That makes it very hard to survive there. And also there is no atmosphere, and there are cosmic rays hitting your body, and within a few years will destroy, most cells in your brain. So it's really dangerous, and you have to hide underground. So, we started on Earth by being in caves just to protect ourselves from harsh weather, from the rain. If we ever go to Mars, we really need to go to these lava tubes that were created by volcanic activity like we have in Hawaii. These are caves that have enough of a ceiling to protect us from cosmic rays. And Elon Musk is not thinking about it, he's talking about, but frankly, it's not about humans. I don't think the future in space will be to send humans to interstellar journeys. It will be to send AI astronauts. And that's why if I imagine an encounter with passengers from another distant planet, I would imagine encountering AI astronauts. These are, if they are functional. And of course, the first thing is to find them. The second thing is to interpret what are they seeking. And to interpret it would be a very big challenge, because we might need to use our AI systems to interpret their AI systems. It may take us a while. It's not a trivial task because we don't speak the same language. So it will be more difficult than the enigma, breaking the enigma during the Second World War that Alan Turing was engaged in. But we will use our best computers to do that. And our AI systems may feel kinship to their AI systems more than to us. So we shall see how they help us, GPT-5 and future versions of it. But it would be exciting, and I see it as an opportunity for us to learn from a civilization that had more time to develop its technologies. And it's a shortcut for us to figure out what our future might be like, because they went through that future already. And we might see technologies that we cannot imagine, like iPhone 100 instead of iPhone 15. It would look to us, perhaps some of the gadgets would look like a miracle, because, I see it also as an opportunity of unifying religion with science, because very advanced scientific culture may do miracles as far as we are concerned. They could, for example, create life in their laboratories, or if they understand how to unify quantum mechanics and gravity, they might engineer a baby universe in their laboratories. These are creating a universe, creating life, are qualities that we assigned to a divine entity in religious texts. And so it may all be a good approximation to an advanced scientific civilization. And therefore, we will be at awe when we meet it. But it will be in reality, in difference from talking about religious ideas, which are not evident to us through our telescope.
If that's possible, then you're not ruling out the idea of multiverse.
Okay, so the multiverse, let me first explain what it means. We see out to a distance that light traveled since the Big Bang. The Big Bang is the time we see the universe expanding, and if you go back in time, you can find a point in time when everything was on top of each other, like the density was infinite because we are expanding. So there was a time where the density was infinite. So everything started expanding at that time. And that is called the Big Bang. It happened 13.8 billion years ago. One simple way to find out how long ago it happened is to take the recession speed, the speed by which distant sources of light, like galaxies, are receding from us. And we know the distance of those galaxies. So we take the distance, divide by the recession speed, and we get the time that it took them to recede away from us. So if you go back that much time, they were just on top of us. The density was infinite. So that's the Big Bang. So the question is there anything beyond the distance that we can see that light traveled since the Big Bang? Okay, and the answer is there must be. The conditions should be quite similar. There cannot be a cliff just outside the observable volume of the universe, because otherwise it would affect our universe. If there was an edge somewhere, then we would notice it, because there would be so-called tidal forces that distort the uniformity of our region of space because of gravity. We can actually say, based on what we know about the observable volume of the universe, that the conditions that we see, which are pretty much uniform throughout this observable volume, they continue to a distance that is 4,000 times bigger than the region that we can see, 4,000 times bigger. So that means the volume where the conditions are similar to what we see is 4,000 cubed times bigger. Okay, so that's a huge volume. So we can see maybe 1 trillion galaxies within the observable volume, like the Milky Way, and there are 4,000 cubed times 1 trillion more similar galaxies that we can't see. Now, beyond that, we don't know. You know, there could be an edge somewhere. We don't know because we can't go there. And some people conjecture that we live in a multiverse. And what they mean by that is, in fact, if you go far enough, the conditions will change completely. And in fact, it's an infinite space, and everything that can happen will happen an infinite number of times. So if you are a student and you get a C in an exam, you shouldn't be distressed, because there is a copy of you. In fact, there is an infinite number of copies of you elsewhere in the multiverse where you get an A. And to me, you know, that, I mean, why would people talk about that? If it's not easily testable, you can't test if it happens or not. Well, because it offers a solution. We see some things in our observable volume of the universe, like the so-called cosmological constant or the vacuum energy density. And some people say, oh, actually, one way to explain this value, which is not natural at all, is to say, well, this vacuum gets many different values in many different regions, but if it had a different value than we observe it to have, we wouldn't exist. So obviously we would live in a region that has this value. That's an explanation. And I say, well, it's not really an explanation, because we don't know if the other regions exist. So, but nevertheless, so it's a philosophical argument which appeals to people who work in string theory, because they don't offer an explanation to the vacuum energy density. So I say that's a lazy way out, because in principle, if you can't test it, you can explain everything this way. It's also a lazy way out from a student that gets a C, to say that, you know, there is an infinite number of copies of me elsewhere where I get an A. It basically takes away any responsibility from your life. It allows you to imagine everything, and I don't like it. Okay, I want to explain what I see, and I want an idea to be testable before I believe it. But for some reason, it attracts a lot of interest from string theorists, simply because they cannot make a prediction. Their theory implies 10 to the power, maybe even 500 possible vacuum states. And I say, well, your theory is not a good one. I wanted you to make a prediction. And they say, well, we can't make a prediction. Maybe it exists everywhere. Then you ask them, okay, what happened before the Big Bang? And they say, that's too difficult. We can't really make a prediction about that. I said, okay, fine. Here is another place where you can make a prediction, because you're claiming to unify quantum mechanics and gravity. I say, okay, what happened at the center of a black hole? And they tell me that's too complicated. We can't predict it. And in fact, our theory doesn't have a unique version. There are many possible versions. So you see, suppose someone tells you, I'm a plumber, and you say, okay, can you fix my toilet? And that person says, no, sorry, it's too difficult. Can you fix maybe my, I have a broken pipe at home? No, that's too complicated. I can't do that. But this plumber says, I actually can fix things in the metaverse. If you put goggles on your head, the community of people who is willing to put goggles on their head and live in the metaverse will be happy with my skills, because in the metaverse, I can fix all the plumbing problems. That's what he tells you. Now, would you pay that person? I will never pay that person, because only if I put goggles on my head, I will benefit from his expertise. And that's not real. Okay. So nevertheless, for 40 years, you have this community of mainstream physicists arguing that. And in my mind, it's a betrayal of the tradition of physics, which is supposed to describe the reality that we all share.
How do you reconcile this physicists who dream about stuff that are not testable with physicists who deny that Oumuamua might be alien object?
Yeah, this is really interesting, because there is a common thread, as you allude to. The common thread is, don't be too affected by the real world, but believe in wishful thinking. And the main objective of both camps is to show off, to basically use science as a sandbox for demonstrating intellectual capabilities. So in the context of string theory or the multiverse, it's a perfect sandbox, because it will never be proven wrong. It's not subjected to experimental tests, and therefore you can simply show mathematical virtuosity and demonstrate that you are smart. And everyone will applaud, because there is no way of testing you. So as long as you work within mathematics, you cannot be proven wrong. And that's a very safe space for you to operate in if you just want to show that you are smart. If you look at Albert Einstein, who serves as a role model to theoretical physicists, he was actually wrong 3 times between 1935 and 1940. He said that black holes do not exist, gravitational waves do not exist, and quantum mechanics doesn't have spooky action at a distance. These were 3 independent papers. The fact that he was wrong on all 3 counts in a matter of 5 years shows you that he was not trying to show off, but was engaged in a frontier where it's very difficult in a frontier of knowledge to know what is right and what is wrong. So sometimes you make mistakes, okay? He wasn't trying to empower his image. He was just trying to find out the truth, and was wrong 3 times. And the reason we know he was wrong is because there were 3 experimental groups that demonstrated that black holes exist, gravitational waves exist, and quantum mechanics has entanglement. Quantum mechanics have spooky action at a distance. And these 3 groups were awarded the Nobel Prize in Physics over the past 6 years. So the past 6 years, the Nobel Prize in Physics was given to people who had proven Einstein wrong experimentally, okay? And that is the way science is done. That's the way physics is done. However, if you don't put your ideas on the guillotine, their heads cannot be chopped off if they're wrong. And as a result, you're not doing a service to our scientific knowledge, because we don't know if there are extra dimensions. We don't know if the multiverse exists. It may be flattering to your abilities to do mathematical virtuosity, but that's not the goal of physics. I mean, you can become a mathematician, but this is not physics, where you're supposed to compare ideas to experiments. So that's convenient. And at the same time, people who are experts on space rocks, it's convenient for them to pretend that there is nothing new. Because if there was something new that they missed, that they did not anticipate, that represents a revolution, a breakthrough in our understanding of the cosmic neighborhood, then suddenly their stature as experts is eroded, okay? Because their self-esteem is based on past knowledge. And if you talk about new knowledge, it's as if you were telling the clergy back 400 years ago that the earth moves around the sun. So what was the reaction to this new knowledge that Galileo Galilei tried to advocate for? The reaction was, we will put you in house arrest so that nobody will listen to you. And that was politically a wise move, because it suppressed the voice of Galileo at the time. But today, when we send the Orion spacecraft that goes around the moon and we look at the Earth, it's obvious that the Earth moves around the sun. It's a blue marble that keeps orbiting the sun. So we know that Galileo was right, and the Earth continued to move around the sun, irrespective of what the clergy said. But it was useful for their social acceptance or political power to put Galileo in house arrest. Today, he would have been canceled on social media. And you would think that within 400 years, we would learn the lesson. We would learn the lesson to attend to evidence when it's intriguing and to use it as an opportunity to learn something new. But what you see through the examples that I mentioned is that no, that in fact, instead of advocating maybe religion, we now advocate the multiverse, you know. But the point of the matter is, if you can't test it by experiments, it's just a belief system. So what's different? I'll give you another example. I had lunch just a few months ago with a person who I asked, you know, theoretical physics. I said, what's your most important accomplishment? And he said, well, it was work that I did about supersymmetry, and I'm still very proud of that. Now, supersymmetry is a new symmetry of nature that was tested in the natural range of parameters by the Large Hadron Collider, okay? And nothing was found, so it was proven wrong. It doesn't exist in the natural range of parameters. And this person knows that, but he's still proud of his work, as if nothing happened. What did it remind me? It reminded me of the Lubavitch community in Brooklyn, who believed that the rabbi, and that was like decades ago, they believed that the rabbi will be the Messiah, okay? So they actually built an apartment for the rabbi in Israel. So that is an identical replica of the apartment that he had in Brooklyn, in Crown Heights, so that he would find the toilets when, you know, when he dies, he will come back as the Messiah, he will go to Israel, to Jerusalem, and he will have an apartment that is familiar to him. So that was the idea. They built a replica so that he would find the toilets. And then the rabbi died. Okay? So now here is a data point, just like supersymmetry was not found by the Large Hadron Collider in the parameter space where people forecasted it. What was the response of the Lubavitch community? That is a religious community. The response was to say, okay, he doesn't come back, we see that. Let's just wait. Okay? He might come again. He might come. What is the response of the person I had lunch with about supersymmetry? Oh, we just need to build the next accelerator. It's just around the corner. This was my most successful paper about supersymmetry. So I say, okay, what's the difference between a religious community that does not accept the verdict of evidence and a scientific community at the frontier of physics that does not accept the verdict and moreover works on things that will never be tested?
That's sad.
It's just human nature. But pretending that science carries the torch of rationality and evidence-based work is not a true depiction of the way science is done in academia, because I'm giving you examples. When there is intriguing evidence that something may be new, it's being shoved under the rug. And when there is an opportunity not to be confronted with such evidence, people celebrate for 40 years. They're happy about it because their ideas cannot be proven wrong.
Well, they make a living out of it, right? There's no reason for them to shoot themselves in the foot.
Well, no, but they can make a living, just like Einstein made a living. They can make a living and enjoy the fun of trying to figure something out and sometimes being wrong, okay? By comparing their ideas to experiments. That's fun. Okay?
About ego.
If it's not about yourself, if it's not about your ego, you know, it's just like an athlete trying to break, you know, to run faster, you know. So there may be younger people that run faster than you, but that's not the point, because you try to challenge yourself, and there is clear, you know, you can immediately see the consequences of what you do. So that's the spirit of physics, where if you have a good idea, you should make it testable, and then, you know, you learn something new. Even if it's wrong, you realize, okay, I was wrong, let's move on.
I want to ask you about the Starshot project. Humans can't move with the speed of light, obviously, right? But Starshot project have some sort of solution that doesn't get close. But can you kind of elaborate a little bit on that project?
Right. So the idea there was, a wealthy entrepreneur and former physicist, Yuri Milner, came to my office back in summer 2015 and asked me if I'm willing to lead a project that will attempt to reach the nearest star system, which is Alpha Centauri, within our lifetime, within a generation, which means like 20 years. And I knew that this star system is about 4 light years away. So if you want to get there within 20 years, you need a spacecraft that moves at a quarter of the, or a fifth of the speed of light. And that is very challenging because this speed is about 1,000 times faster than our chemical rockets, 1,000 times faster. So chemical rockets that we send to space moved 1,000 times faster than Henry Ford T-car, the first car that was invented. So we made a huge leap from the car to spacecraft, and that was a factor of 1,000 in speed. And now we're talking about making another leap by a factor of 1,000, and that sounds very challenging. And I told him, I'm very intrigued, but I have to think about it, whether it's possible, if there is any technology. And 6 months later, we identified only one technology that can do that in a feasible manner, and that is pushing a sail, a very lightweight, thin membrane with a powerful laser beam. And the advantage of that is that the spacecraft does not need to carry the fuel. The main limitation to rockets is that they carry the fuel with them and then they throw back the burnt gases from the fuel, and that's what propels them. It's the same mechanism that propels a jet plane. I once flew from the US to Europe and calculated how much fuel you need to push the plane across that, and it works out. You just need to throw back, and the speed at the characteristic speed at the characteristic thermal velocity of the molecules of burnt gases from propellants, and so you can figure out how much fuel you need to carry to make the journey. And but if you carry the fuel with the rocket, you need to accelerate it with the rocket. That's why the amount of fuel that you need to carry grows exponentially with the terminal speed that you want to reach. And that means that you are very limited to a terminal speed that is about 10,000 times slower than the speed of light. And that's why all the chemical rockets we send to space move roughly at the same speed, somewhere between 15 kilometers per second to maybe 35 kilometers per second, all the through the entire history of spacecraft, from Sputnik to New Horizons. So the question is, how do you get 1,000 times faster? And that's if you don't carry the fuel. That's one thing. And the second is if you push your spacecraft with light, because then you can reach the speed of light. The light will catch up with the spacecraft. And the mechanism is really simple. It's just like the same mechanism that pushes a sail on a sailboat, where it's the wind, the air molecules are bouncing off. Here it's the particles of light, photons, that are bouncing off the sail. And we calculated that if you take a sail of a few grams in weight, and then you use a laser beam of 100 gigawatt that shines for a few minutes on a sail the size of a person, then it will get to a fifth of the speed of light across a distance that is 5 times the distance to the moon. So that was the concept, and we are still in the process of developing crucial components of this technology. It's very challenging, but it's something to think about. And of course, there could be probes passing through the solar system that were propelled by the same technology, but our telescopes are not sensitive to them because they will appear just as a single image. Astronomers will not know what to make of it because they won't catch multiple images of those things, and they would move too fast. And especially if they are small, the size of a person, there is no way. I mean, the sensitivity that we currently have for survey telescopes like Pan-STARRS is 10,000 times too low, too weak for us to see such objects. So unless, of course, they collide with the Earth, in which case they would appear as meteors.
So those sails, what are they made of?
Well, that is actually a relatively straightforward technological challenge, which we already have a solution for. I mean, There are various materials that you can make that are a micron thick, like 10,000 times thinner than a centimeter, than the thickness of your thumb. Those are very strong, tough, and they have a high reflectance for a laser with a wavelength of a fraction of a micron. So we already have a solution for that. The biggest challenge is really making the laser beam and communication across the vast distance of space.
The way I understand the laser is lightsabers and Star Wars. Like, what's a laser then? Is it the?
Oh no, it's just many of these together. So each unit could be already in existence. It's just that you need to put a lot of them to get to 100 gigawatt of power. You also need to store the electric power, and so that's a challenge because you need to add those many laser beams coherently together to make one powerful beam, and it's not trivial, and it will take time to develop that.
And they're not going to destroy the cells technically. They're just going to push them.
Oh no, the idea is that the most important thing is for the cell not to absorb much energy, to reflect everything or let it go
got
through.
it.
But you cannot allow the cell to absorb more than 1 part in 100,000 of the power impinging on it. Otherwise, it will burn up. It will be, just like Daedalus' wings in the ancient Greek mythical story, where it would just burn it up.
So that technically, that laser beam then can be a very powerful weapon.
It could be. That's of course an issue, but if such a launch facility is under international supervision, such that many nations make sure that it's not being used for any military purposes. But you're right that the same technology, when aimed at Earth, could be quite devastating.
Time travel.
Mm-hmm.
Is it possible theoretically?
Based on Einstein's theory of relativity, no. And also Stephen Hawking wrote a paper which forbids the concept of closed time-like curves, which basically means that no time travel is allowed, because he argued that otherwise it will be a problem for physics, and somehow the laws of physics forbid it. We don't know it for sure. It leads to contradictions in the sense that you can change history by going back in time, and then it will not be consistent with the history that we know. And at the moment, we do not have any viable solution for a space-time that would allow us to do that time travel. And some people suggested maybe those unidentified aerial phenomena represent technologies from the future of humanity that come back in time and visit us. These are just speculations, and of course, if we ever see evidence for that, or if we ever develop theories of quantum gravity that allow that, the situation will change. But as of now, I would assume that there is no way to travel back in time.
You're the scientist, and you spent your life looking at the cosmos, right, and analyzing things. But you have dreams. When you have dreams about cosmos, like what type of dream is that? Like, what do you see?
Okay, so my dream is that I will be taken to space, let's say on one of the commercial flights of either SpaceX or Blue Origins or Virgin Galactic, and then something will go wrong and I will float into space in my spacesuit. And of course, I may die shortly afterwards, but that is not relevant for the rest of the story. My hope is that Jupiter, the planet, will give a gravitational kick to my body so that it will escape from the solar system. And then it will float in interstellar space. And then after 1 billion years, will collide with an exoplanet that is habitable. And I will burn up as a meteor in the atmosphere of that planet. And there would be a scientist, an astronomer on that planet that says, look at this interstellar meteor. Let's check what it was made of and have an expedition to the ocean and collect the fragments from my body and put them on display at a museum. And that would be the greatest honor that I can receive from another civilization, to recognize that I existed.
I'm sure there will be some scientists who deny it as a rock or some other stuff that doesn't worth looking.
Yeah, that's
But from perspective of like dreams that you see at night, do you ever see like dreams of actually floating in the space? Do you see other planets? Like, what is the most realistic thing you see?
Well, the thing is, when I go out at night and look at the stars of the Milky Way galaxy, they look like lights from cabins in a giant spaceship moving through space, because the Milky Way is moving through intergalactic space, cosmic space, and it's dark. And all the stars look like lights from cabins. And I often wonder if there are any other sentient beings in those cabins looking out and participating in this cosmic journey. And the reason I care about, I seek intelligence in outer space is because I don't often find it here on Earth. And I want to learn from them. If you look at human history, it was shaped most of the time by a group of people trying to feel superior relative to other people. And that is unfortunate, because if there is a smarter species out there, it will teach us that all the differences among us humans are insignificant, and we should treat each other as equal members of the human species. Okay, and we can learn from them if they are much more developed than we are, and it will save us time. And entrepreneurs, for example, can make a lot of money by importing technologies that other civilizations developed. So I see it as a learning opportunity. Of course, we can insist that we are alone. And in fact, one reason to do that is to claim that we are the smartest that ever existed since the Big Bang. And, I think, obviously, if you are single and you claim that there is nobody else out there, then you can win the competition. But if you want to date someone, that will improve you. The only way to do that is to admit that you may not be alone and to go to dating sites. Because if you stay at home and say that you are the smartest and there is nobody else out there, you will never find a date. You will never find a partner. And, the Nobel laureate Steven Weinberg, in his book, The First 3 Minutes, towards the end, he's talking about the fact that cosmologists try to figure out the universe, and the more the universe appears comprehensible, the more pointless it looks to these cosmologists. And I say that Steven Weinberg, as well as the people that study cosmology, including myself, in the past were focused on lifeless objects like elementary particles, matter, radiation, stars, galaxies. And of course, these are pointless. They don't give us a meaning to our existence. But if we ever find a partner out there, it's just like finding a partner in your personal life. It gives a meaning to your life. So we will find the universe not so pointless at that point. We could learn from that partner. And that, I hope, is my biggest heritage. And I talk about this at length in my new book, Interstellar, to be published in August 2023. So in 4 months, you will see more about this theme that I was just mentioning.
I saw it in Amazon. It says most anticipated book in science. I'm like, that's perfect. Yeah,
I didn't know that. I can tell you that last week I had 20 filmmakers and producers approach me about making a documentary about my research, and I had to turn all of them down because I already have someone doing that. And also I had a Zoom call with a playwright that he sent me an email and said that had the title Avi Loeb on Broadway. And I thought it's April Fool's Day joke, that he is just trying to fool me. And then he attached photographs of him with Dick Van Dyke, that was in Mary Poppins, and with Barbara Streisand, and these photos had the serial number of his cell phone. And so, I spoke with him, and he's serious about it. And so there is a lot of interest from the general public, also from government. I had visits from high-level officials from government that are interested in the Galileo project and what we are doing. And of course, the work of government is complementary to what we do. They care about national security, and we care about anything else, things that have nothing to do with national borders. So we complement them in a way. That's the scientific inquiry into whether there is anything extraterrestrial. That should be open data shared by all humans. That's our approach. And so, there is a lot of interest out there, but there are a lot of pushback, that, a lot of friction with colleagues in academia that just want it to go away. And, frankly, I never got engaged in this endeavor. I would never get engaged if there was no evidence to intrigue me. The fact that Oumuamua showed up, the fact that these meteors appear unusual, that's what keeps me going. And I have no account on social media. I don't care how many likes I get. And frankly, what the colleagues say is not more relevant to what the clergy said back in the days of Galileo.
And you're going to have a play about you on Broadway. How about that?
Well, it's just starting to be made. And so we shall see. But it's really not my goal. My goal is to check out if there is any package in our mailbox, basically. That's really simple. That's what I care about. Everything else is just distractions.
And when we're going to hear the first results from the expedition to the ocean?
Hopefully by the end of the summer. So we don't have the date yet finalized, because we are still waiting for some various administrative details. But we have the funding. There was an entrepreneur that I had a Zoom call with, and he provided $1.5 million, and he said, no problem. Charles Hoskinson, and he will join us to the expedition. And so we are funded. We have the boat. We have an exceptional team with some of the best people in the world that ever went on ocean expeditions. And so we are well equipped, and I just saw the testing of the machinery that we plan to use just a couple of days ago. And so things look good. It's just that we didn't finalize the date, but hopefully we'll have results by the end of the summer. And of course, I should warn that, it's a very challenging task to find those fragments, and we might not find anything. So, but that's the way science is done. As I said before, you have to take risks, or otherwise you won't find anything.
Well, I wish you good luck with that expedition and your endeavors, and looking forward to your book. Looking forward to read more in articles, and thank you very much for being on the podcast.